Hello there, I'm Thomas, the pilot flying the Airbus A340-300 and the Boeing 737-800, and I'm having a new video, a flight from Zurich International Airport back to Zurich International Airport with the Airbus A340-300. I'm going to make some brief system explanations and an engine start sequence before takeoff, and we're going to be flying a flight level 250 to 25,000 feet with Mach 0.82 maybe, or 340 knots maximum speed. So I'm going to show you now the aircraft systems and do an engine start sequence. So this is the Airbus A340 cockpit. You can see here the primary flight display. We have the airspeed displayed here. The minimum airspeed is 0.4 knots. The airspeed here displayed with blue is the airspeed selected here in the flight control unit, in the autopilot unit, which is 100 knots right now because it's before takeoff preparation. And here is the airspeed tape that shows the airspeed as the airspeed increases while we use the thrust levers here. If I move the thrust levers all the way, let's say, to the takeoff go around, you can see the manual takeoff go around here. And you can see this mode here also displayed in this screen, the upper ECAM display, electronic centralized aircraft monitoring display. You can see here the N1, which is the low speed front fan low pressure compressor stage, which is 93.7% right now. The exhaust gas temperature is 846 degrees. The N2, which is the high speed rotor, high pressure compressor stage of the engine, it's 98.4%. The fuel flow is 13,740 20 pounds right now per hour per engine, and we have 72,640 pounds of fuel. Let's move the thrust levers back. Now I'm gonna use the reverse, so I'm gonna show you here. You can see the reverse is armed here, maximum reverse. You can see the thrust reverse is here. It's the reverse of the engine flow. I'm gonna show you one more time. You can see I'm using this to operate the engines and the side stick. Here we have also the altitude tape, the barometric altitude tape, which is 1,430 feet right now above mean sea level, with QNH 29.92 inches of hydrargus. And here we have a true or magnetic compass. We have the limits of the side stick over here, these corners. We have the horizontal and vertical guidance of the side stick. When I move the side stick like that, you can see I'm changing. There is a fly-by-wire system in this aircraft which changes the G demand of the aircraft. This causes the flight control surfaces like the ailerons, the spoilers, and the elevators to change their attitude in flight, which causes the aircraft to bang roll or pitch up or down. So I'm gonna keep showing you some more of this. You can see here the side stick. I'm gonna explain this in another episode, the fly-by-wire system. So maybe I'm gonna do the engine start right now. Maybe I'm gonna use first the APU selector to on. We need some auxiliary power unit here. Here we have the APU. I'm gonna be very brief for this episode. So here we have the APU start sequence. displayed in the lower ECAM display. The APU generator is still off. We can see in the electric alternate current here. We also have the APU generator off. And this is the left and the right wing engines generators producing 115 volts, 399 Hz of alternate current, and they operate at 48% right now. And I'm gonna show you back the APU again. Here we have it. The APU is starting. It's gonna be available in a while. The APU generator. We're gonna use this to start the engines. Here it is, becoming available in the electrical system and the bleed air system, which is gonna pressurize the hydraulics also. So if I'm gonna turn off the engine generators here that produce electric current, I'm gonna show you very fast this thing right now. Here we have the ECAM. I'm gonna pop up the ECAM to show you a better view of that. What I mean. So here is the engine generators conductors, the IDG, integrated drive generator, that produce electrical power. So if I'm gonna turn them off right now, here I have a sensor, electric direct current, electric alternate current. Here we have it from the left wing, engine 1, engine 2, and engine 3 and engine 4 from the right wing. So if I'm gonna turn these two off, I'm gonna stop having electrical power from the engines, but we keep having electric power from the APU. So if I'm gonna turn the APU off, the APU generator off, you can see we have no electrical alternate current from the APU. We only have direct current here, and here some screens went off, and we have this warning over here: electric DC bus, AC bus, there is fault from the electrical system. So I'm gonna turn them back on again. So we can turn either the APU. I'm gonna turn all the engines. I'm gonna turn the APU now. So here we have it, it's connected in the electrical system, as you can see. So you can see it here displayed in the ECAM. So I'm gonna turn the APU back off again. So I'm gonna turn the generators on, and I'm gonna turn the engines off. I'm gonna show you in the, here is the hydraulics. I'm gonna talk to you about another time. The green, which is the engine 1 and engine 4, which also has a RAT manual on in case of failure of the engine driving generators or the engine. We have an extended pump which extends in the air and pressurizes the hydraulic green system. So we also have a backup for the yellow and the green and the blue with electrical pumps. I'm gonna talk to you about that another time. And here is electric DC conditioners, flight controls, and the fuel. Here we have the fuel pumps, which I'm gonna talk to you about another time. So if I'm gonna turn off the primary pumps, you can see them here going off, this symbol. If I'm gonna turn and the standby off, we're gonna have no fuel into the engines, and the engines will go off. So if I'm gonna turn the X feed on, now every engine is supplied from any pump. So it doesn't matter if only one pump supplies the engines. It's gonna have the fuel pumped into every engine through this X feed line, which is on right now. You can see here. So I'm gonna turn them back open. I'm gonna turn the X feed off. We don't need this right now. We're gonna show you, here is a bleeder. We're gonna use this for the engine start. So we need the APU bleed on. Here's the APU. You can see this off. It's going off, it's disconnected. Now it's on. And here I'm gonna turn the engines off for the engine start. And the packs, I'm gonna turn them off. So maybe I'm gonna use this, the engines on here. I'm gonna use only this in the closed position. So here we go again. I'm gonna turn the engine master switches off, which is gonna turn off the low and the high pressure fuel valves and stop the ignition. You can see the engine's going out now. Here we have no engines right now, so we're gonna start them very quickly. You can see here and here the engine just stopped, so I'm gonna try to start them very quickly. Here we have it. It's no engines right now. I'm gonna set the engine start selector into the ignition start over here, which is going to initiate a few things in the engines, like the FADEX is gonna close the packs. It's gonna start the engine starter, which is compressor inside the engine, accessory gearbox, if I remember quite well. So here we have what bleed. You can see the bleed lines here. It's on the APU feeding the lines, and there is the isolation in the left, between the left and the right side. You have more pressure in the left side. So I'm gonna show you here the engine view. You can see the electrical also here. You can see the electric AC, the alternate current. There is no generator right now from the engines because all the engines are off. No electrical power from them. So I'm gonna start the engine master switches here. Maybe both of the 1 and the 2. You can start both engines in one go. Let's see the engine spinner here. You can also hear it. When the N2 is gonna reach 20, the high pressure fuel valve opens. You can see the N1 is increasing very rapidly. The left engine start. Now we're gonna start the right wing engines. Gonna use this in the auto position. So I'm gonna turn these two on to have the engine 3 and engine 4 here. You can see now we have the message that the FADEC is initiating the starting process. I'm gonna show you the other side. Now we start these two engines. So here it is for the engine start. So right now I have to set up this. Next page, I'm gonna set the block fuel here. 0 fuel weight, center of gravity. So we have a fuel of 73,000 pounds, I think. Yeah. So gross weight is 391. So maybe we have 370. I hope this is gonna work. So 0 fuel weight. Yeah, block fuel is 74,000 pounds. Here we have all the fuel on board the aircraft, which is gonna used by the flight management guidance computer to manage the flight plan and the flight path of the aircraft. So we have block fuel 34. I'm gonna input this. What is it? 74.0. Takeoff weight 390,000.6. So we are correct. Here's our gross weight now, 387,980. And gross weight center of gravity mean aerodynamic chord is 28.7% of the Mach mean aerodynamic chord line. So we're gonna use this for that. For the center of gravity trimmable horizontal stabilizer pitch spring for the takeoff setting. So I'm gonna use make a very fast flight plan right now. In the initialize page our departure and arrival airport, Lszh to Lszh. Cruising flight level 250, align the RS. So we're gonna have it very fast. Flight number, we can leave this in this format. So this is a departure over here. A little bit more bright, I think. Yeah, because it's dim, it doesn't look so good. So we're gonna have a little bit more brightness now. Yeah, this is what we need. Departures are available runways. Runway 14. Trans to Alpha. Yeah, this is our start. Arrival. We have it displayed here, the flight plan. So we're gonna have the arrival, same airport and same runway. LS14. Not really. Okay, now we have no discontinuities in our flight plan. So I'm gonna show you a little bit. Here's the primary flight display, the flight mode annunciator I'm gonna talk to you about later. So here we have the flight path flight plan here. I can show you some more, maybe airports, and I'm going to increase the range. I'm gonna set the ILS on. We're almost ready to take off. So I'm gonna use flaps 2. The pitch stream is correct. And we can display it here in the flight controls. Yeah, here you can see I'm moving the ailerons, the spoilers, the rudder, and the elevators, like that. You can see it here. It's fully working, so we have hydraulics and electrical controls. So performance, I'm gonna use flaps 2. 2 degrees up. So maybe we're gonna have V1 and V2. Maybe I'm gonna insert them on my own 145. $150 and $155 maybe, and $160. And we're ready to take off. I only need to set over here. So the speed is managed right now. The heading should be managed actually, and the altitude, it should be 35,000 feet for this flight. So I'm gonna use this manage. We're ready to take off actually. You can see in the primary flight display the ILS localizer here, which is aligned with the runway heading 139 degrees, and the IQL is the runway ILS and localizer frequency for this runway. You can see our flight modes here. The auto thrust mode here, our managed airspeed 155 knots for takeoff, our managed glide altitude, the SRS, which is also displayed, which is the vertical and the horizontal guidance, and the flight directors and auto thrust display. Here is the flight guidance of the aircraft. I'm gonna talk to you about later. So here we have it. We're actually ready to take off. So I'm gonna use a full takeoff, go around thrust here. We can see here displayed and locked over here in the flight mode annunciator. Disconnect the brakes. Here we go. We have maybe 30 more minutes for this flight. Here we almost reach our V1, we rotate, and V2. V1, we rotate, and we take off. Retract the landing gear. This is the Airbus A340-313X or 311 as you like to call it. You can see our airspeed right here. This is 170 knots, it's going 175 and it's keeping increasing. Our altitude is 2540 barometric above sea level, and our radio altitude is 1240 feet above the ground level. So we are 1320 feet above ground right now. You can see the takeoff go around level climb right now is armed. I have to use the climb button for the engines here. Instead of using the takeoff go around full power. So I'm gonna start banging into the flight plan, flight path I'm gonna follow for this flight. Maybe decrease a little bit rate of climb to accelerate a little bit. Maybe use MCT, manual MCT. I can use continuously the MCT for climbing the aircraft, climb faster and accelerate faster. So here we have it, the primary flight display, the flight mode annunciator, our airspeed tape, our stall speed. This is the alpha protection speed, the yellow indication here, and the rate tape is the alpha max, which the alpha prot is going to initiate the alpha prot protection system, which I'm going to talk to you about later, which is a kind of anti-stall system for this aircraft. This is our altitude right now, 6,500 feet. This 1,400, 500, it's a rate of climb, 1,500 feet per minute vertically. So this is the navigation display. This is the first waypoint, 4 nautical miles, the top of which is not displayed right now. So correctly, I have to use the other. So gonna use a direct to the next waypoint, to the Zui. Yeah. So here we have it correct now. We're going direct to the Zui. 7.4, 7.3, we are approaching this waypoint into the map. You can see it here. We have some airports here. Here is Germany, EDSN, EDTD, EDSI, EDSL. It's this way. You can see Germany from here. This side of the map, which is north and northwest. This side is the Switzerland and maybe the Italy. This way. Italy and Austria, this way. I like the view of Germany over here. We were flying it every time. You can also get a side view of the aircraft. The Airbus A340-313X. This is a sweet view of that. You can see the 4 engines of the aircraft. It's a very powerful aircraft actually. You can see how we keep climbing. This is the red symbol is maybe I'm gonna use manual thrust instead. Yeah, I'm gonna increase the thrust rating here. And you can see it over here, the flight control unit, the autopilot unit. Here's autopilot 1, autopilot 2, This is the airspeed, the heading, the altitude, and the vertical speed. This is the localizer and the auto throttle, which is on right now. It's active. You can see it displayed with blue here in the flight mode annunciator. I'm gonna start making a turn now to the next waypoint on the map. We have a lovely view of Germany here. We have some star sign. You can see the outside view over here. So this way is Germany, this way is Switzerland, Austria and Italy. And after that is France. You can see how big this aircraft is. It can hold up to 309 passengers, I think. Maybe even more in some configurations. I have another maybe 20 minutes for this flight, so I'm gonna try to accelerate a little bit, climb a little bit further. Make this flight faster. Gonna try to land the faster I can, so maybe increase the airspeed a little further. Why not? You can see here in the ECAM display the rate of engine power right now, which is 91% in the low speed fan stage, low pressure compressor, and 93.8%, which is the high speed high pressure compressor stage of the turbofan engine. Our fuel flow is 7,440 pounds per hour per engine, and we have 64,330 pounds fuel. So we're in a good position. You can see the flight controls here. Our pitch stream I was telling you, which right now should be automatic. I can input if I want some pitch stream. This is gonna frozen the automatic pitch stream for a while, like a minute or two. The DTM, this must be Dortmund airport, but I'm not sure. So if I'm gonna increase this a little bit further, yeah. This is Munich DMN, if I remember well. Here's German this way. I can also see the France, some parts of it, into the map. Here Lszh, this is part of Switzerland. France actually is in the south. We're gonna see it later when we return to the airport. So maybe I'm gonna use takeoff go around a little bit further I can use it for 10 minutes to climb faster a little bit, because we're gonna need another 3 minutes to get into the maximum altitude. This is the rate of climb, 3.5 minutes. Airspeed is quite low. You can see the stall speed margin over here. See how high we fly right now with this aircraft. We're gonna have contrails in a while. You can fly all the way up to flight level 410. It's about 12,000 meters. So I'm gonna retract my flaps in a while, just to increase the airspeed. Maybe I'm gonna accelerate a little bit, like that. Have to pay attention not to reach this margin. It's not going to activate the alpha protection. This is our altitude, 25,200 right now. It's selected, and our airspeed 254 knots selected. This is the target airspeed, and this is the target altitude. This is the altitude we fly right now, 21,500, crossing with 700 feet per minute rate of climb, and our airspeed is increasing from 175 knots to 180 knots. This is our horizontal situation right now with respect to the world. Told you this is Munich airport, somewhere here. So this is Switzerland this way. I'm gonna have chemtrails in a while. And we retract all the flaps to increase our speed margin. So I'm gonna climb a little bit further and take the turn back into the airport. So we have 16 minutes to go to the airport. You can see how we turn over here with respect to the world. Our heading right now is 70 degrees to the northeast, 80 degrees here, 35, 78, 79, 80. We keep heading east right now, and then southeast. So east is maybe the Austria, yeah. So here we have it for the chemtrails now. You can see the vapors formed by the engines. I'm gonna show you later this effect coming back because we have reached our altitude and we cross it, so we have to climb down a little bit further. So now I'm turning back to the airport. We have another 15 minutes to go for this flight. Here is the flight path we're gonna follow. Here's the altitude. We're going to hold this altitude for a while. So maybe I'm gonna have to increase my airspeed a little bit. But it's managed to 300 knots, so I don't have to do anything at all. Increase the airspeed, the MCT denton. So I'm gonna fly with maximum airspeed right now with this altimeter while taking this turn. It should be right now a turn of 33 degrees maybe, which is the maximum without continuous side stick input. We can take it all the way to the 67 degrees with maximum side stick input, but we need to keep using the side stick command to turn the aircraft all the way to the 67 degrees. But if we turn to the 33 degrees, we can leave the side stick and leave the aircraft turn on its own, because it's balanced completely by the flight controls, fly-by-wire system. So you can see we have the chemtrails over here. Yeah, here we have it. So we need to use a direct to the airport final fix. So F114. We're gonna fly direct to the airport now. Here you can see France actually, LSPL, LSMN. Okay. So I'm gonna decrease the range here to have it more clear where we are. We're going back to the airport. We have one traffic over here, one aircraft. It's minus 1,200 feet below us. In front of us. Here we have it. The other aircraft traffic. You have to pay attention for that, because we might gonna cross some aircraft in our way while we fly. So we're gonna have to start descending a while. We're 33 miles away, so it's a good idea to start descending. So going to decrease the altitude here. To the 7,000. So we're gonna start descending right now with maximum airspeed, maybe. Here we have it. I have to decrease the airspeed a little bit, the airspeed margin, before descending. So we have 10 more minutes to go. You can see the aircraft is descending right now. You can see the chemtrails. over here. So I'm going to decrease the airspeed margin. Here we have it. To 50 knots for the approach. So maybe I'm gonna come a little bit closer into the airport. We have 9 minutes to go, so I'm gonna use a little bit more airspeed. We have 8 minutes to go. For this flight. So we need to get closer to the runway. While we descend, have 5 and 2, 7 minutes to go. We're overflying the airport, so we need to be in a good position. While decreasing our altitude. So we overspeed a little bit more. Use the speed brakes again. Decreases fast. 16,000. We have to descend very fast. We're very close to the runway right now. Here we are. Here's the runway. We're gonna land. Runway 14. So we have to turn a little bit further and make a steep descent. We have 6 more minutes to go, so this is it. I got delayed. So we have to make a fighter jet approach and landing this time. "9,000 feet, keep descending." So I'm gonna start turning, maybe. Yeah, we're close to the runway. Have to descend a little bit further. So this is it, 5 minutes to go. We're in the river. We're very close actually. Need to descend a little bit further, extend the speed brakes and the landing gear. This is gonna slow us down. And use maybe some flaps Here we have a few more minutes, 5 more minutes for this flight. We have some clouds now. I'm gonna use maybe full flaps for this landing. Okay, here we are in the runway. We have to align ourselves right now with the runway heading. Use the localizer. Turn the localizer. The LS is already turned on. So I'm going to decrease the thrust. And come into the runway heading. This is hard aircraft to maneuver actually. So we have another 4 minutes to go. We have a nice view here. We're gonna make a steep approach for this landing. We're a little bit higher and we have only 3 minutes to go. So I believe we're gonna make it. Here we are, 2 more minutes to go. $500. We level off. 30. 10. 5. This is it. Parking brakes and a reverse thrust. And here we landed. Here we are. A beautiful landing. You can see the landing gear, the nose wheel, the tires and the landing gear. The tires and the struts are perfectly safe. There is no damage to the struts and the tires and the nose wheel. And you can see the thrust reversers here being deployed. So I'm gonna turn the thrust reverser off. We have only 30 seconds more to go. You can see the thrust reversers here being deployed. I'm gonna retract them again. No longer reverse thrust. So I'm gonna show you here. Here we have the tires. So the fuel, the tires. We have no blown tires here. You can see the temperature and the wheels. They're safe. Here's the fuel page I was telling you about. How much fuel we used for this flight. It was 3,360 pounds per engine. For 4 engines. Fuel use 13,400 pounds. They're still available in our inner tanks, in the wings tanks. So I'm gonna talk to you about later. So this was Thomas, the pilot flying the Airbus A340-300 and the Boeing 737-800. I'm gonna see you in the next flight. Thank you for joining me. I'm gonna talk to you about the aircraft system.